The architecture of large language models is built upon the principles of neural networks and attention mechanisms. The most prominent architecture in this domain is the transformer, which has been key in enabling the development of the powerful LLMs that we see and use today. Understanding the components of this architecture is crucial to understand how LLMs process and generate human like text. The transformer architecture was introduced by Baswani and others in this paper. Attention is all you need. Feel free to pause the video and scan the QR code to navigate directly to the paper. This one right here. The transformer is the foundation for many LLMs due to its parallel processing capabilities and efficient attention mechanisms. If you scroll down a bit in the paper, you'll get to the diagram that shows the architecture. Let me make it a bit nicer and easier to read. Here are the things that you need to know about in the transformer architecture, namely the encoder-decoder structure, self-attention mechanism, multi-head attention, positional encoding, and feed-forward neural networks. Let me talk a little bit more about each one. The transformer consists of an encoder and a decoder. In the context of LLMs, the encoder is what's responsible for processing input text. That's basically the text that you type or send, while the decoder generates output text. It's simply the input and the output. Then, at the core of the transformer is the self attention mechanism. It allows the model to weigh the importance of different words in a sentence relative to each other. This mechanism enables the model to capture contextual relationships and dependencies efficiently. In simpler words, each word in a sentence looks at all the other words in the same sentence and figures out how much attention or importance it should give to each of those words. Then it combines information from all those words based on their importance to get a better understanding of the whole sentence. For example, it's not the same to say the general of the army or a general understanding. General is the same word, but it has a different meaning depending on the context. Then, multi head attention. To capture different types of relationships, the transformer employs multi head attention. It performs self attention multiple times in parallel, allowing the model to focus on different parts of the input simultaneously. Let me put it like this. Imagine that you have a complex book to read. You then divide the book between you and a few friends, and each one of you and your friends reads a part of the story and understands it. And then you all help each other understand the whole story. Also, since the transformer doesn't inherently understand the sequential order of words, positional encoding is added to the input embeddings. This helps the model differentiate between the positions of words in the sequence. In simpler words, numbers are given to the words in the sentence so it understands where the words are located, making better sense of the text. Then each layer of the transformer includes feed-forward neural networks, which process the attention outputs and apply nonlinear transformations to capture complex patterns. They are like little decision-making machines inside the model. They help the model process and understand information. And yes, that was a lot to take. So let's use an analogy.